In the previous video, we took a deep dive into the pluggable storage architecture. In this video, we will look at configuring NFS 4.1 data stores. We are going to take a look at NFS 4.1 features and benefits. We will go into some detail into configuring an NFS 4.1 server. I have one that is configured at this point in time, and we will then look at seeing how on the web client side with ESXi we can then actually configure an NFS 4.1 data store based on the shares which are being exported by that NFS 4.1 server. And then I'll go through the entire process of actually configuring the NFS 4.1 server for you as well. There's a new command in ESXCLI, which is the ESXCLI namespace, which is NFS 4.1 in vSphere 6, and we will explore that as well, along with looking at the various IP connections that are in place when we actually have the NFS 4.1 data store operational. So we are here at the VMware vSphere 6 Documentation Center. Let's take a look at NFS protocol version 4.1 and the various considerations we need to understand. So one of the biggest features of NFS 4.1 is that it provides multipathing for servers that support session trunking. So when this trunking is actually available, one can use multiple IP addresses to access a single NFS volume, and that's what we have in place with our Fedora 24 server. Client ID trunking is not supported on the ESXi hypervisor. It is supported, I believe, with other hypervisors such as KVM. Some of the downsides does not support the hardware acceleration, and so cannot create thick virtual disks on NFS data stores. You are restricted to thin provisioning. Of course, the other aspect is the Kerberos support. With Kerberos support, ESXi, to my understanding, provides the encryption of the header on the data packet or the storage packet that actually flows, so that there can be no man-in-the-middle attacks. It does not encrypt the actual data itself. Since data storage networks are in place in very secure data centers, and usually the storage networks are isolated from all the other networks, including, and the switches are hardened with port security and so on, it's very unlikely that somebody with a sniffer or something can actually look at the data packets. So it's more than sufficient. In fact, some may wonder why you actually need Kerberos within the data center. But if there is a requirement, a security requirement to do that, at least one can encrypt the header and be assured of no man-in-the-middle attacks. NFS 4.1 is different from NFS version 3. It has inbuilt file locking, and then the locking mechanisms are now, with this implementation in vSphere 6, are left basically up to the NFS 4.1 protocol, and there is no modification of the client side as it is on ESXi with NFS version 3. So you can support non-root users if you have Kerberos, but otherwise we use the traditional non-Kerberos mount for our example. So root access guidelines, of course, have to be in place, and you have to do a no root squash to be able to support. So you cannot have the auth.sys, which is the old NFS version 3 style, or Kerberos mounts simultaneously. If you use Kerberos, you cannot support IPv6, but if you use auth.sys, you can support both IPv4 and IPv6. So really, in practice, I would imagine because of the multipathing, it's probably the biggest factor that is a plus for NFS 4.1. To my mind, even more than Kerberos, because the current Kerberos support is restricted to using Windows Active Directory Kerberos. So I'm logged in here into a Fedora server. This is Fedora 24. The reason I'm using Fedora is simply because it provides me the latest capabilities. It's sometimes bleeding edge. Some things don't really work very well, but for this purpose, actually, I think it serves very well because it supports NFS protocol version 4.1. And the process of setting up the server is also quite well documented. So let me go full screen on the view. So here we are on a clear Fedora terminal. Let's key in rpc info-p to see what's going on. If you look down in the middle up here, you see that version 4 of NFS with TCP on port 2049 is supported, as well as version 4 of NFS on UDP on port 2049 is also supported. The next thing to check would be the etc password. So let's see if we can find a NFS kind of a user in etc/PASSWD, and we see that the NFS nobody user, which is the anonymous NFS user that's used in NFS 4.1, is actually present. So this Fedora 24 distribution does support what we are actually looking for. Let's look at IPADDR to see what our NICs are doing. So here is ENS33. It has an address of 192.168.0.6, and it also has a secondary address of 106. There's ENS37, and that has an address of 192.168.0.16/24, and there's no secondary address, as well as ENS38 is there as well. So what we have here is that we have 3 NICs in place. They're all on the same subnet or network as the rest of the system, and they are up and running at this point in time. Now let's go through to the web client and see what we can do there. So now we are back in our vSphere web client. We are on our familiar server 192.168.0.201, related objects, data stores. And what we're going to do is to go into actions and go into storage and create a new data store. The data store will be of NFS type, and let's look at the options available for NFS 3 before we demonstrate NFS 4.1. When I key in next, obviously the data store name has to be specified, the share folder has to be specified, as well as a server has to be specified, and basically here it is that you would be keying in one address, which is really the big difference between NFS 3 and NFS 4, as we will just see. So we will cancel out of this again and go through the process of creating a new data store one more time. We'll look at NFS, next. This time we'll select NFS 4.1 and see what the differences are. Well, we need to create a new data store name, so we will create data store NFS 4.1. The folder that I'm serving out is /srv, and we will see that shortly when we go into the details of how I configured that server, the Fedora server. We saw that the server had 3 NICs, and the IP addresses were 192.168.0.6. I will add that in here. Then I'll add the second one, 68.0.16, and then the third address was 192.168.0.26, and I click on that as well. This is obviously NFS 4.1 because we are specifying multiple addresses for exactly the same folder. Click on next. Not going to do Kerberos as we said before, and so here we have it. It's type NFS, version NFS 4.1. The NFS servers, there are these 3 servers, and the folder that's being served out is the /srv folder with no Kerberos. I click finish, and the system is going through its motions. Refresh, and here we have data store NFS 4.1, and its status is normal. Now let's go into this data store and browse it, and there's already a file that is out there, so we are actually being able to access files on that data store. It's now time to look at the actual connections. Remember, we entered 3 different IPs for the same server, for the same folder. Keep that in mind: 192.168.0.6, 0.16, and 0.26, and we'll see what the connections look like on either side, both on the ESXi side as well as on the Fedora NFS 4.1 server side. So I'm back in 192.168.0.201 command line. Let's just go back to our root directory, ESX CLI network IP connection list. We are looking to see what kind of IP connections we have for this ESXi host. Okay, let's look at our foreign address. We're looking for 192.168.0.6, 16, or 26, and 192. Here we are. Here we go. So what we have here is 3 sessions that have been established from our ESXi host, which is .201, from port 625, 624, and 623 to the NFS port of 2049 out there. And you can see there's something called NFS 4.1 SM session queue that's in place. So basically we have 3 sessions through 3 separate IPs over to the same folder that we are serving out on NFS Fedora. Switching over to the Fedora side of the house, let's take a look at netstat AT, which gives us the active TCP connections. And right down in the middle up here, you can see the Fedora server. The NFS is 2049, and you can see we have 3 connections. We have this one to ESXi 201. We have a second connection to ESXi, and then we have the third connection, NFS connection, over to ESXi. It's actually pretty interesting, the words after the colon. These actually denote the port number. I think we had 624, 625, 636. So these are previously defined IANA ports. One, I guess, for DEC DLM, and OOB something HTTP, and something for crypto admin. So just like instead of saying 2049, they translate it to NFS in the same way. Instead of saying 624, 625, and 623, I believe it was on the other side, they actually use the name that's out there. It's kind of interesting and a little bit weird, because these must be really old defunct protocols if ESXi is reusing those ports, because remember, they are privileged ports. So it's kind of interesting that they actually do that. Okay, few other things we can take a look at. Some of the commands up here. So the new network management commands. There's CLI that goes with the network manager on Fedora, NMCLI, dev status. Okay, we saw that there were NICs here, with 3 different IPs, and the other ones that are being used up there. So with this, let's go into some of the configuration that I did on this side, having shown that all this actually does work successfully. Let me go through that process for you. So clear the screen, and one of the very first things to be done is what we just saw was RPC info-p. So you have NFS version 4 that's available for TCP, because that's what's being used at this point in time. Then what we had to look for grep NFS. We already did this in /etc/password. So NFS nobody is there, so we are in pretty good shape there as well. Then there were some firewall commands that had to be entered, and those firewall commands were like this. So firewall command, again, this process is documented in the Fedora 24 documentation. So I had to change zones. So --zone equals internal, so that the proper ports would be opened up for those services. Add service equals NFS, which I had already done. And then the other one was RPC bind, and you'll see the same come up again. And then it was mount D, and this was already done as part of my process, but I'm showing this to you just to show you what I actually did. The next thing to do is to do a firewall command reload. So firewall command --reload. So that reloads the new rules, and of course that would be successful because I haven't really changed anything at this point in time. There is a new mapper that's used, which is in etc. So we can cat it at this point in time because I've fixed it already. Cat etc. This is the ID mapper, ID mapd dot configuration. And some of the changes here, one was I had to put my domain in there and then do the mapping of the nobody user to NFS nobody and nobody group to NFS nobody. And of course this is what I had checked earlier. So there were three lines that had to be changed. I had to put my domain, just site.local, and then this little bit up here, nobody user. Okay, so that's the change that I had to actually make there. So we quit out of that. The next thing that I had done in setting up this server was to enable the various services, three services here, the RPC bind, the RPC ID map daemon, and the NFS service. So this Fedora 24 uses systemd, so the command is system control enable E and the services RPC bind dot service NFS ID map dot service and NFS server dot service. Okay, so that's done. So basically these will start up anytime I reboot the system, and then of course those services had to be started, so they already are running. So I don't want to restart them because we have a NFS 4.1 data store in place. So when I key and start, see what happens. Okay, so they're all up and running. Nothing much happens. Now let's look at something called export file systems. Let's see what file systems are being exported. Export FS, this is one word. And what we see up here, I use the verbose qualifier up there. So /srv is being served out on the 06 address. It's read write with no root squash, and the security system says it's not Kerberos, and we have no root squash in place with the for everything. The interesting part about this versus an NFS3 is that the same folder is being served out 3 times on 3 different IP addresses. Okay, and this is basically NFS 4.1. Let's see exports, and we can see that this is the file basically in there. Looks exactly the same. Specify no root squash. The same folder being served out at 3 different IP addresses. And so that is basically the configuration that's done out here on Fedora 24 to set up the NFS 4.1 server. And we saw there was nothing much that had to be done out on the VMware side of the house at all, because all we had to do was to go in there and specify that it's going to be an NFS 4.1 data store. We specified the multiple addresses and it was up and running. Now let's go back to the command line on 192.168.0.2.1. So we had left it here. I will clear it. ESX CLI NFS 4.1, and that is unknown namespace because the word storage has to come first. STTORAGE NFS 4, that's the namespace. So operations on volume parameters, you can add a new NFS volume to the ESX source and mount it. We can list the NFS volumes currently known to the host, and we shall do that. So NFS 4.1 list, and we can see that we have data store NFS 4.1 mounted. These are the hosts. It's one single share. It's accessible, mounted, and it's read write, and so on. Now we can just take a quick look at the other options that we have up here. So we can have NFS 4.1. So let's see what we have available here. And you can get or set the volume parameters of NFS 4.1 volumes. So let us look at NFS param get, hit the enter key. You can just say all to list, and we see that the only sole data store NFS 4.1, the max queue depth is 32, the max read transfer size is this, and it's this. Now some of this can be changed in the advanced configuration options as well. There is a section for NFS 4.1 that's available. You can change the max queue depth there as well, but looks like you can change it here as also. You can take a quick look at how that would be done. It would be a set command, and we hit the enter key, and it's going to say, well, which one do you want to change and to what? So set dash queue, instead of 32, let's make it 48, and we will put the volume name down as DATASTORE-NFS 4.1. And it's not, the set max queue depth is not yet implemented for NFS 4.1 client, so although it says it up here, it's not present at this point. So very little that can be done here except for the client list. NFS 4.41 list basically gives you your data stores and what is happening, and that's really all we need to know. So we have just configured NFS 4.1 data stores. We looked in depth at what I had to do on the server side. We are using Fedora 24. It was very trivial out on the ESXi side of the house. Of course, I was using the non-Kerberos option. Using the Kerberos option requires basically a Windows Active Directory Kerberos, which I do not have in place. But my view is that within the secure confines of a physical confines of a data center, you really should not need to use Kerberos at all if the security has been implemented properly on your storage network. So let's look at the next video that we have in place for you, which is configuring iSCSI data stores, which I think you'll find exciting, and I look forward to seeing you there.